Hello friends, welcome to Learner's Planet. Friends, this is our geometry workshop, and particularly in this workshop I am going to discuss trapezium. Going to be very important topic as far as CAT is concerned and other entrance examinations are concerned. A good number of problems based on trapezium are frequently asked in CAT, CMAT, XAT examinations. So in this session particularly, what we'll be doing? We'll be doing a complete postmortem of trapezium, right? And I would suggest you to attend the basic sessions of geometry, advanced session of geometry before you come for this workshop, right? So you'll feel comfortable while we are dealing with the various aspects of trapezium. Okay, so let's begin this session. Now friends, when I'm discussing trapezium, I suggest you have your paper and pen. Just note down the important things about this, right? This trapezium I have drawn over here. It's A, B, C, D, right? The first thing that it is one type of quadrilateral having four sides, right? And the sum of the angles is 360 degree, right? That is very basic thing. After that, in case of trapezium, we have one set of parallel lines. That means at one set of lines will be parallel to each other. Okay, that's here in this case AB is parallel to CD, right? See, if there are two sets of parallel lines, then it will be either a rectangle or a parallelogram or a rhombus, right? But in case we are having one set of parallel lines in a quadrilateral, then it is a trapezium. Okay, so in other words, you can say a trapezium has just one set of parallel lines. Okay, so AB is parallel to CD over here. Sum of the angles is 360 degree, as I've already told you, right? You just note down the things. First thing, one set of parallel lines. Sum of the angles is 360 degree. Third, what is the area of this trapezium? I assume this height to be h, this length to be x, this length to be y. That means x and y here are the lengths of the parallel sides, parallel lines. Okay, and what will be the area? I assume this point to be P, right? Area of this trapezium will be half sum of parallel sides, that is x plus y, into distance between them, or we can say height of the trapezium, that is h. Okay, so this is what the area of a trapezium. Okay, sum of parallel sides into distance between them and divide by 2. Okay, now friends, we have some interesting facts related to trapezium. The first is a circle can be inscribed in a trapezium only if sum of parallel sides is equal to sum of non-parallel sides. So here x plus y is equal to maybe I assume this to be, say, L and M, right? So x plus y is equal to L plus M. That means sum of parallel sides should be equal to sum of non-parallel sides. Then only a circle can be inscribed in a trapezium, right? Second thing, a trapezium can be inscribed in a circle only if it is isosceles, right? That means L should be equal to M. Okay, if you want this trapezium to be inscribed in a circle, then this length must be equal to this length. Okay, now a circle can be inscribed in a trapezium and a trapezium can be inscribed in a circle. Both the conditions should be clear in your mind, right? The next thing is this triangle COD is similar to triangle AOB. In this trapezium, AC and BD are diagonals. They are intersecting each other, not necessarily bisecting. They are intersecting each other at the point O, right? So when they are intersecting each other at point O, we are getting 4 triangles, right? In that case, COD, triangle COD is similar to triangle AOB, right? So if the two triangles are similar, all the sides will be in proportion, right? All the sides will be in proportion. Apart from that, their areas will be on the in the ratio of square of their sides, right? So what I can say, area of triangle COD by area of triangle AOB, right? COD AOB. What is the corresponding proportion sides? That's y and x, right? This is the base, this is the base. So triangle COD and triangle AOB, that's y square by x square. That means areas will be in the ratio of square of their sides, right? Similarly, areas will be in the ratio of square of their altitudes, respective altitudes. Maybe the length of this altitude is suppose say D, and length of this altitude is suppose say k, right? So it's d square by k square, right? That means if the two triangles are similar, their sides will be in proportion, their altitudes will be in proportion, their angle bisectors will be in the proportion, their you can say medians are also in the proportion, right? So if the two triangles are similar to each other, then their areas are in the ratio. That property is very useful while we'll be solving the problems based on trapezium. Okay, now here in this case, see, if I consider triangle ADC, what will be the area of triangle ADC? That's base into altitude, right? So what's the base? That's y, and what is the altitude? H, right? So area of triangle ADC is equal to half, base is what? Y, altitude is what? H, right? Now what is the area of triangle ACB? Half, base, that is x, what's altitude? That's h, right? Now friends, we are having two triangles, triangles ADC and triangle ACB. In both the cases, the length of the base is same, height is same. That means area of triangle ADB will be equal to area of triangle ACB, right? That is the property that the triangles having same height, or we can say they are between the same parallels and they are having the same base, then their area are equal. Their areas are same. So in this case, triangle ADB and ACB will be having same area because both of them are between the same parallels and they are having the same base. So area of triangle ACB and area of triangle ADB will be same. Okay. Similarly, if we see this triangle ADC and triangle BDC, in this case the base is DC and height is H only. So in this case also the area of triangle ADC will be equal to area of triangle BDC. So that's this. Okay. So these are the basic properties of triangles which are formed inside the trapezium by intersection of diagonals. Okay. Now let's discuss some more about trapezium. I am having here an isosceles trapezium. That's ABCD. This length is equal to this length. I assume this to be P and this to be also P. This complete length is X and this length is Y, right? Height of this trapezium is H. So this is H and this is also H. Okay. And I drop a perpendicular over here. So this length maybe A, and this is also a perpendicular. This length is B. So precisely A plus B is H, right? Now what is the area of this triangle? That is half of y into a. I suppose this is O. Area of triangle OCD is half of A into Y, right? Area of triangle AOB is equal to half of X into P, right? Area of triangle ADC is equal to half Y into H. Okay? Now we know triangle AOB is similar to triangle COD. If two triangles are similar, their areas will be in the ratio of their square of their sides, or we can say altitude as well, right? So area of triangle COD by area of triangle AOB is equal to x square, COD, so that's y square by x square, or we can say a square by b square. Now we assume this to be, say, k, right? Y square by x square is equal to a square by b square, that is equal to k. That is the ratio of area of these two triangles. Okay. Now I am having this triangle AOD. Triangle AOD. Now what will be the area of triangle AOD? That will be triangle ADC minus COD. Triangle ADC minus triangle COD. Right? Now ADC is what? Half of Y into H. COD is what? Half of A into Y. Right? So if I take half Y as common, what I'll be getting? H minus A, right? H minus A. Now what is H minus A? That's B. Okay, so what will be the area of triangle AOD? AOD, that is half of Y into B, right? Similarly, if I find out the area of triangle COB, it will be same, because this length is like same as this length, right? So area of this triangle will be equal to area of this triangle, right? Now if we write the ratio of all the four triangles, that is COD, DOA, AOB and BOC, what that will be? I write it over here. COD, that area is half of A into Y is to area of AOD, that's half of Y into B, area of AOB, half B into X, and area of OCB, that's further half A into Y, right? So that's AY is to BY is to BX is to AY. Sorry, just, yeah, right? So this is what the ratio of all the four triangles, right? This is in the case of when we are discussing an isosceles trapezium, right? If the trapezium is not isosceles, this length P will be differ, and according to that, here we will be getting a different answer, right? But you should be clear with the concepts and how we have found out all the area. That is clear in your mind, I'm sure now. Now we have considered this ratio y square by x square, a square by b square is k. Suppose we consider this to be k square, right? So what will happen? Y square will be equal to k square x square, or we can say y is equal to kx, right? So that can be replaced over here. So that's a kx, b kx, bx, a kx, right? So in that case x is cancelled, x is cancelled, x is cancelled, x is cancelled. So we got the ratio AK is to BK is to B is to AK, right? So that's also very simple, right? various properties, concepts related to trapezium I'm discussing over here, and that one of them or more of them will be used when we will be solving the problems, right? So let's take one of the problem now. In that particular problem, we'll be discussing the entire thing once again, right? But in that case, we'll be having the values for x, y, p and all that. Okay, I hope you are clear with the concept and you are ready to discuss the problem. Now here we are having a problem, a trapezium ABCD, AB is parallel to DC, AB is 3, DC is 5. So that's A, B, C, D. This is 3, this is 5. The two diagonals intersect at point O. I make the diagonals. So this is the point O, right? Now, if the area of triangle AOB is 18, find the area of ABCD. Now, we have been given the area of this small triangle AOB. That's 18, right? We are given the sides of this as 3 and this is as 5. Now we have to find out the area of the entire trapezium. Okay? Now the concept that we will use over here, triangle AOB is similar to triangle DOC, right? So if the two triangles are similar, their sides are in ratio, right? Similarly, their altitudes will also be in the ratio, right? So altitude of this and this is suppose 3K and 5K, because the base is 3. So altitude will be 3K. We have to use a constant over here because altitude may be 3, maybe any other bigger number, right? So this is 3K and similarly this is 5K. So the ratio of all the sides will be same in both the triangles since they are similar to each other. Okay. In that case, the entire length, right? That is 3K plus 5K, 8K. That is the length of the trapezium. Okay. Now, what will be the area of this trapezium? That is half of sum of parallel sides, that's 8, into distance between them, that is 8K. So that is the area of ABCD, right? But we don't know K, that we have to calculate, right? Now for this triangle, what is the area? That is base into altitude. Base is what? 3, altitude is 3K into half, and this area has been given to us as 18, isn't it? So that's 9, 2s are 18, that means K is equal to 4, right? So if K is equal to 4, area of ABCD will be 32 into 4, so that's 128. So what will be the area of ABCD? That's 128 square units, whatever the units we are using over here. So that's 128 square units, right? If the concept of similarity is clear in your mind, then it will be really very easy to solve this problem. Okay? Now friends, we will move one step ahead. We will be finding out the area of triangle AOD and BOC both as well, right? Now what is happening over here? What will be the area of triangle AOB? That's base into half of base into altitude. What is the base? 3. So half of 3 into altitude is what? 8K, right? So that's 4 into 3, 12K, and K is 4. So 12K into, just writing down over here, 12K. So that's 12 into 4, 48. So area of triangle ADB is 48. Area of this triangle is 18, that we are already given, and area of this complete triangle is 48. That means area of this part will be what? 48 minus 18, we can say 30. Okay. So we got the area of this part, that's 18, area of this part is 30. We find out area of this part as well. So that's half 5 into 5K. K is 4, base into altitude. Half base, that's 5 into altitude 5K. Instead of K, I am putting 4. Right? So 5 5s are 25 into 2, that's 50. Right? and area of this will also be 30 because base is same and altitude is same, so this will also be 30, right? So the area is 18, 30, 50 and 30. Sum of all these four must be 128. And you might have observed that how easy it is to find out the area of each part if the concept of similarity is clear in your mind, right? So the concept we have discussed to solve this problem will be some of them, and more of them will be used in solving other problems also. That's why I have found out the areas of other triangles as well, because maybe this question is also asked, right? Now I have this problem. Here, in a regular hexagon ABCDEF with side this, the diagonal AC and FB intersect at point O. Find the ratio of areas of triangle ABO and pentagon OCDEF. Now, I have this regular hexagon. I just name it A, B, C, D, E and F, right? Now, diagonal AC and FB intersect at point O. I just complete the diagram. This is AC, this is FB. So AC and FB are intersecting at point O, right? Now what I do, I match FC. Okay. Now you can very well observe that we are getting a trapezium ABCF. AC and BF, they intersect each other at O. Now this side is given to be 6√3. Okay. Now we have to find out the ratio of areas of ABO, that means AOB and OCDEF. That means this complete pentagon and this, right? Now the problem can be very easily solved. See, we matched FC, right? So below FC, this is half of hexagon, and above FC, that is remaining half of the hexagon, right? Now what we have to do, we just have to find out the area of this portion, right? Area of this portion, if we get this and this will be similar triangles, so we'll be getting the area of this as well. Okay, now listen to me carefully. Now friends, see what happens. This triangle AOB and FOC, since they are similar, that I have already told you, and AB is actually half of FC. FC is what? The longest diagonal in this regular hexagon, right? So in a regular hexagon, the longest diagonal is actually double of the side. So if AB is 6√3, it will be 12√3, right? So this length is double of this. That means area of this triangle will be 4 times than that of this. So I assume the area of this triangle is suppose K, then that will be 4K, right? Now see, this is the altitude of this. I write K over here. This is the altitude of this triangle and this is the altitude of this triangle. If side ratio is 1:2, then altitude ratio will also be 1:2, right? So suppose this is X, this is 2X. So this is length X, this is 2X. Now what will be the area of this triangle? FAB, that is base into altitude, right? Now base is whatever, maybe X or Y or whatever, but altitude is this X plus 2X, 3X, right? Now if we compare this triangle APF to triangle AOB, base in both the cases it is same, but height is in this case, in triangle AFB, height is 3X. In case of AOB, it is X. That means area of triangle AFB will be 3 times than triangle AOB, because height is 3 times, right? In this case it is X, and in this case AFB it is 3X, right? So area of triangle AFB will be 3 times area of triangle AOB, right? So if area of this is K, then area of AFB will be 3K, right? So if it is K, AFB is 3K, that means AOF must be 2K, obviously. If it is 2k, it will also be 2k, right? So in all, 4k plus 2k plus 2k plus k. So 4, 5, 6, 7, 8, 9. Area of the upper part is 9k. Similarly, area of the lower part is 9k. Getting my point? Now what we have to do? We have to find out the area of ABO and OCDEF. AOB is what? Area K. OCDEF is what? This 9k plus this 4k, 13k. So that's 1:13. Isn't it very easy? Very simple logic we have used. Listen to me once again, though I have already explained it to you by taking these sides. See this triangle, the base is same, but in case of AOB and AFB, the altitude of AFB is 3 times than that of the altitude of AOB. This is x, and in this case it is 3x, x and 2x, right? So area of triangle AFB will be 3 times than that of AOB. So if AOB is k, AFB will be 3k, and if AOB is k, then AOF will be 2k, right? So k, 2k, 4k, 2k, right? So this is the story, and this FC is actually the diagonal, longest diagonal, that means upper half and bottom half is same. If it is 9k, it will also be 9k, right? After that, it's very easy. 9k and 4k, 13k, that is the area of this pentagon OCDEF, and area of AOB is k, so the ratio is 1:13. Very simply it can be solved. Okay, now let's discuss this problem in detail. On a semicircle with diameter PQ of length 9 cm, a chord SR is parallel to diameter. So this is PQRS. SR is parallel to this. That means PQRS is a trapezium, right? And the length of QR is 6. QR, that means this chord is of 6 cm, right? This is the center. This is length 6. Now if it is 6, it has to be 6. Reason? Because a trapezium can be inscribed in a circle only if it is an isosceles trapezium, right? So if it is 6, it has to be 6, right? Now we know the length of PQ, that's 9, right? We have to find out the length SR. Now there are various methods to calculate the length of SR. We will be discussing each and every method. So in the process you will be like doing the entire postmortem for this particular problem. Okay. Eventually the concept should be clear in your mind whatever the approach you take. Okay. The first method that I am discussing over here, what I do, I drop a perpendicular from this place to this, right? Similarly from here to here, right? Now what? Suppose these points are A and B, right? So whatever the length of AB, the same will be the length of SR, because ASRB, now it is a rectangle, right? Now I assume this length to be X and this length to be Y, right? And this is the radius of the circle, right? So if 9 is the diameter, radius of the circle will be 9/2, right? Now x square plus y square will be 36. Pythagorean theorem I am applying, right? Over here, see from this center to point P, OP is 9/2 radius, so OA will be 9/2 minus x, right? OA will be 9/2 minus x. So 9/2 minus x whole square, OA square plus AS square, that is y square, is equal to radius square, that is 9/2 whole square. So it's 81/4, right? If I open that up, 81/4 minus 2 times 9/2x plus x square plus y square is 81/4, right? Now x square plus y square is 36, that means 9x is 36, that means x is equal to 4. Now if this length is 4, this length will also be 4, right? So 4 and 4 eliminated, the remaining length from this point to this point will be 9 minus 2 times 4, that's 8. So it's 9 minus 8, that's 1. So length of SR is 1, right? So this is the one method that I have shown you over here. Let's try to do this some with other methods also. Now what I do, I draw the diagonal of this trapezium. Right? Now what? So this is angle in semicircle, so this angle must be 90 degree. This length is 9, this length is 6. So PR will be what? Root of 81 minus 36. That is root of 45. Root of 45 means 9 into 5. So we can say 3 root 5. So this length is 3 root 5. Right? Now area of triangle PRQ will be what? Half of base into altitude. So half of base is 9. Altitude we don't know. That's I just write this PB. And alternatively what you can do, since this is a right angle triangle, we can take this as base and this as perpendicular. So that's half of 6 into 3 root 5. Right? So this way we got the length of PB, that is 2 root 5. So PB is actually 2 root 5. Right? So we know PB, we know this, so we can calculate X. Right? Or suppose this is Y, that means X square plus Y square is 36. Right? So X square, now we have to calculate. Y square will be what? 2 root 5, or we can say 20. Right? So Y square is 20, that means X square is 16, or we can say X is 4. So this is 4, this is 4, the remaining length is 1. Okay, this is this is how you can solve the problem. The third method that I'm going to discuss, let's see. Now this is actually shortest and sweetest method to solve this problem. See, in this case we will be using the concept of similar triangles. Friends, in a right angle triangle, suppose any right angle triangle I'm having, right, this is right angle. I drop a perpendicular from this point, from vertex, or we can say this point to hypotenuse. Then this triangle 1, this triangle 2, and this entire triangle, all of them are similar to each other. That is the property I'm going to use over here. Getting my point? If you have a right angle triangle, from this vertex, if you drop a perpendicular on hypotenuse, then you'll be getting two triangles. These two triangles and the original triangles are similar to each other. Right? The same funda I'm going to use over here. Now our right angle triangle, that's PRQ, that is right angle triangle, because it is angle in semicircle, so it's 90 degree. And RB, suppose it is Y, it's perpendicular over here. Right? That means what? This BRQ and PRQ, both of them are similar to each other. Right? If the two triangles are similar to each other, that means their sides will be in proportion. Now you should be knowing how to write sides in proportion if two triangles are similar to each other. Right? So whatever you take, in the numerator you can take the smaller triangle, in the denominator you can take the sides of the bigger triangle. Right? Be careful about it. Now see, the two angles are equal. Which two angles are equal? See, this angle Q, that is an RBQ, that is common between PRQ and BRQ. Right? That means angle Q is same, and this angle is 90 degree. Over here this angle is 90 degree. That means both the triangles are similar to each other, as I've already told you. Right? Now how will you take the sides in proportion? Just listen to me carefully. In the smaller triangle, the side opposite to 90 degree is 6. In the bigger triangle, the side opposite to 90 degree is what? PQ, that's 9. Right? In the smaller triangle, side opposite to Q, that is the same angle, is BR, or we can say Y. In the bigger triangle, this PRQ, the side opposite to Q is PR, right? And the third length, this is 6, this is Y, the third length is X. Now this is Y, this is PR, the third length is 6, right? If we eliminate this, X by 6 is 6 by 9. That means X is what? 36 by 9, that's 4. So this length is 4, this length is 4, the remaining length is 1, right? So you see, in this case, there is no paperwork required at all, right? Very simply you can solve if you are conceptually clear, right? So similar triangle is, you can say, the properties of similar triangles can be used to solve various problems based in geometry, right? So must be knowing, and you should be able to take the sides in proportion. For that I have already mentioned the method, right? Just take the angles, same angles and the corresponding sides. Okay, practice with that. So friends, in this session we have discussed various aspects related to trapezium. In the next session we'll be taking some more problems, more concepts related to trapezium. Going to be an interesting topic. So watch this session carefully, practice with the problems, right? I'll see you in the next session once again. Bye bye.